All right, today we're going to talk about something you see every single day. Water. It's so familiar, right? But it's also kind of mysterious. It's literally why life is even possible here. And this is the big but, managing it is one of the toughest challenges we face as a species.
You know, they call Earth the blue planet, and it makes sense, right? Water covers more than 70% of the surface. But here's the crazy part, the paradox. Almost none of that water is actually usable for us. A whopping 97% of it is saltwater. Okay, so what about the other 3%? Well, most of that is locked up in glaciers or hidden deep underground. When you do the math, it turns out that all of human civilization, everything, depends on just a tiny fraction of 1% of all the water on the planet. Wild.
So, here's what we're going to cover. First, we'll get into the basic science. What makes water so special? Then, we'll look at how we use it, for farming, in our homes, and for all sorts of industries. And we'll wrap up by tackling the really big challenges, how we manage and, sometimes, try to move this incredibly precious resource around.
Okay, let's dive right into that first part. What exactly makes water so, well, special? Before we can even talk about the politics or the huge engineering projects, we've got to understand the science of H2O itself. Turns out, water is basically a chemical superstar. It has these 6 really unique properties, and it's how they all work together that makes it the absolute perfect ingredient for life. Seriously, these aren't just some random facts for a quiz. These properties are the reason, the only reason, our planet is teeming with life.
Okay, let's zoom in on one of these properties, high heat capacity. So what does that mean? Basically, water can soak up a ton of heat without getting much hotter itself. Think of it like a giant thermal sponge. This is why the oceans are so important for our climate. They act like a massive planetary thermostat, absorbing heat and preventing these wild extreme temperature swings. It keeps things stable for all of us. And here's another one of water's amazing quirks. This one is really weird. For almost every other substance out there, the solid form is denser than the liquid form, so it sinks. But not water. Ice is actually less dense than liquid water, and that's why it floats. It seems simple, but think about what that means. Lakes and rivers freeze from the top down. That layer of ice on top acts like a blanket, insulating the water below so that fish and everything else can survive the winter. Pretty cool, right? So a huge chunk of the fresh water we can actually use isn't even on the surface in rivers or lakes. It's hidden underground, stored in these massive natural reservoirs we call aquifers. The best way to picture an aquifer is just like the slide says. It's a giant underground sponge made of layers of sand and rock that's just saturated with water that slowly flows through it.
All right, so those unique properties make life itself possible. But for us, for human civilization to grow, we had to do more than just find water. We had to figure out how to control it. And that story really starts with farming. I mean, agriculture is, by a huge margin, the #1 way we use water.
So if you're a farmer, feeding the world means you need to irrigate. But it's this constant balancing act. You're always weighing the pros and cons. You can see here you've got options like flood irrigation. It's cheap, which is great, but man, it's super inefficient and can waste a lot of water. On the other end of the spectrum, you've got drip irrigation. It's incredibly efficient. It puts water right where the plant needs it, at the roots. But it's expensive to set up. It's a tough call for farmers to make. Okay, so farming takes the biggest slice of the pie, for sure. But our need for water doesn't stop at the edge of the field. Let's shift gears and look at how water powers pretty much everything else. Our homes, our industries, our whole modern world, really. Just stop and think about your day so far. I bet you've already used water in, a dozen different ways, and you probably didn't even think twice about it. But then you zoom out from our personal lives, and you see that water is the absolute lifeblood of industry. It's used for everything, cooling massive power plants, as a key ingredient in chemical processes, and even for shipping goods all around the world. And if you want to get a sense of the scale, just get a load of this. In a big city like Los Angeles, the amount of water that goes just to sinks, showers, and toilets in a single day could fill a giant football stadium from the field all the way to the top row. That really puts into perspective how much clean, drinkable water we use every day. Now, hearing a stat like that can feel a bit overwhelming, I know. But the good news is we can absolutely make a difference through conservation. And it's not just one thing. It's everything from big companies redesigning their factories to be more efficient, all the way down to us choosing plants for our gardens that don't need a lot of water. Every little bit really does help. Okay, so this brings us to a really crucial question. We've got all these competing needs, right? You've got farms that need water, cities that need water, industries, and let's not forget nature itself. So, who gets to decide who gets the water? This, my friends, is where things start to get really complicated.
Believe it or not, in the U.S., your legal right to use water completely depends on where you live. It's like two different worlds. In the eastern part of the country, where there's generally more water, they follow what's called riparian rights. Basically, if your land touches a stream, you can use the water, as long as you leave enough for people downstream. But out in the dry West, it's a totally different system called prior appropriation. It's literally first come, first served. The first person to use water from a source gets a legal right to that amount of water forever.
And if you want to see how this plays out in the real world, look no further than the Colorado River. It's the perfect case study. So many different states in the U.S. have rights to its water, and they all pull their share out upstream. The problem is, by the time the river finally gets down to the border with Mexico, there's barely anything left, and what is left is often so full of salts that it's basically unusable. As you can imagine, that's created a huge international conflict. So that leads us to our final section. When you have these kinds of problems, what's the solution? Well, often, it's a massive engineering project. We call them water diversions. The idea is simple. Move water from a place that has it to a place that needs it. But as we're about to see, these grand solutions often create a whole new list of problems. And to really get a handle on both the promise and the peril of these projects, we're going to look at 3 examples from all over the globe. We'll head to the American Midwest, then over to the Himalayas in Nepal, and finally to China. Each one of these stories is going to show us the incredibly complex trade-offs that happen when you decide to change the course of a river. First up is the Garrison project in the U.S. The goal was huge: divert water from the Missouri River to irrigate a massive area of prairie land. But it's a great example of how these things can just fail. After spending over $500 million in decades of work, the project just stopped. Why? Well, there was a whole storm of objections. People were worried about flooding important wildlife habitats, about accidentally moving invasive fish from one river system to another, and a lot of people started asking if the insane cost was really worth it for the benefit it provided.
Okay, now let's go to Nepal. Here, they're building this incredible tunnel through the mountains to bring water to the capital, Kathmandu. It's badly needed. But the controversy here isn't just environmental, it's social. The big question is about fairness, about equity. The plan involves privatizing the water supply, and people are really worried that it'll drive the price up so high that the poorest people in the city, the ones who need it the most, won't be able to afford it. And our last example is from China. And honestly, the scale of this project is just hard to wrap your head around. It is the single largest water diversion project in human history. They're moving water over 1,000 kilometers from the south to the north. But an engineering feat that massive comes with a massive price tag. We're talking huge environmental damage, hundreds of thousands of people forced to move from their homes, and ecosystems that are being changed forever.
Okay, so let's just quickly recap the big ideas here. We started with the science, right? Water has these totally unique properties that make life on Earth possible, period. Then we saw how essential it is for everything we do, growing our food, running our factories, living in our cities. But because everyone and everything needs it, figuring out how to share it fairly and use it sustainably is one of the most complex challenges out there.
So I'll leave you with this one final thought to chew on. A river doesn't know what a state line is. It doesn't care about a national border. It just flows. But our laws, our rules, they're all built around those borders. So the big question for all of us is, how are we going to manage a resource that belongs to everyone and at the same time to no one? Finding the answer to that is going to be one of the defining challenges of our time.